Good evening, students. I hope you all are fine, right? So let's start with our today's session. In today's session, we are going to discuss about the chapter that is trigonometry. Okay, so let's begin with this. So first of all, before starting with the trigonometry, I just want to um, make you understand about the Pythagoras theorem. So Pythagoras theorem is basically applicable on right-angled triangle. Now, what is right angled triangle? Right angled triangle is that triangle in which one angle is of 90 degree. Okay. Now, the side opposite to the 90 degree angle is your hypotenuse. And the side which is adjacent to the 90 degree angle and the hypotenuse angle, that is your base, and this is your perpendicular. Now let's say there is this angle, let's say it is theta. So angle theta is between hypotenuse and base, right? And side opposite to theta angle is your perpendicular, right? Now let's begin with the trigonometry. So first of all, there are three important functions, that is sine, cosine and tangent. Now see, what is sine? So sine is the function of the angle which is perpendicular upon hypotenuse. So it is equal to your sine theta. Let's say this is the angle, theta angle, okay? And from this triangle, we have to find out the function of sine theta. So theta is the angle given to us. So sine theta can be found out by applying P by H, that is perpendicular by hypotenuse. Okay. Next is cosine. So cos theta is base upon hypotenuse. Okay. Now comes tangent. So tangent is sine theta by cos theta. Okay. Now see, sine theta is P by H. So it is P by H and cos theta is B by H. So it is B by H. Now see, H and H will cancel out. You will get perpendicular by base. So this is your tan theta. Okay. Now, if in this triangle you know only two values or two values are given to you in the question, that is perpendicular and hypotenuse, and question is asking you to find out cos theta. So first of all, with the help of the value given to us, that is perpendicular and hypotenuse, we will find out the value of find out the value of base. Okay. So we will apply the Pythagoras theorem, that is, so Pythagoras theorem states that hypotenuse square is equal to perpendicular square plus base square. I hope this is clear to you, right? So if any two values are given to you, then you can find out the third one, right? So now let's move ahead with the second part of it. Now we know that sine theta is equal to perpendicular by h and cos theta is equal to base upon hypotenuse and tan theta is equal to perpendicular by base. Now there are more three functions which are basically related to these three functions. So first is your cosecant theta. Cosecant theta is the reverse of sine theta. So it is hypotenuse by perpendicular. Next is your secant theta. Now secant theta is the reverse of cos theta. So it can be represented as hypotenuse by base. Now the sixth function is your cot theta. Cot theta is the reverse of tan theta. So it can be written as base upon perpendicular. Right? Now why are we studying these functions and why are we studying trigonometry? So basically the application part of trigonometry is when we have to find out the height of any building. If angle of elevation is given to you and distance is given to you, then you can easily find out the height of the building with the help of these functions. Okay. Now, I'm going to tell you the table, the values of these six functions at different angles. So now let's make the table. So here is your theta and that is your sine theta. Okay, theta first angle is 0 degree, after that 30 degree, then comes your 45 degree, after that 60 degree, and then 90 degree. Okay, these are the main angles. Then cos theta, tan theta, after that cosecant theta, then secant theta, and then cot theta. Now see, sine theta, that is sine 0 degree, is always 0. Sine 30 degree is 1 by 2. Sine 45 degree is 1 by root 2. Sine 60 degree is root 3 by 2. Next is sine 90 degree is 1. Okay. Now cos theta. So cos 0 is 1. Now just see the pattern. Okay. Cos 30 degree is root 3 by 2. Cos 45 degree is 1 by root 2. Cos 60 degree is 1 by 2. And cos 90 degree is 0. So as you can see that cos theta is the reverse of sine theta here. The values are, if sine theta we are going from left to right, then values of cos theta is the reverse of the values of sine theta. So you can easily learn it. Now tan theta, we know that tan theta is sine theta by cos theta now. So just divide the two values given to you. Tan theta will equal to tan 0 is equal to sine 0 divided by cos 0. Now we know that 0 by 1 will give you 0. Now tan 30 degree is sine 30 degree divided by cos 30 degree. Okay. So 1 by 2 divided by root 3 by 2. So you will get 1 by root 3. Now tan 45 degree is equal to sine 45 divided by cos 45. Correct. If you divide these two numbers, you will get here 1. Now tan 60 degree is equal to sine 60 degree divided by cos 60 degree. If you divide these two numbers, so you will get here root 3. Now tan 90 degree, that is sine 90 divided by cos 90. So 1 by 0 will give you infinity. That is not defined number. Okay. Not defined. Now we know that that cosecant theta is a reciprocal of sine theta. So 0 by 1 is given na sine 0. So cosecant 0 will be equal to 1 by 0. That is not defined. Because whenever we get 0 in the denominator, that number become not defined. Okay. Now cosecant 30 degree is the reciprocal of sine 30 degree. So here we will get 2. Then sine cosecant 45 degree is reciprocal of sine 45 degree. So here we will get root 2. And then similarly cosecant 60 degree is 2 by root 3 and cosecant 90 is 1. Now we know that secant theta is a reciprocal of cos theta, correct? So secant theta is equal to 1 by 1, that is 1 itself. Now root 3 by 2 reciprocal of it will be 2 by root 3, and then 1 by root 2 will be written as root 2. After that 1 by 2 is 2 and 0. 1 by 0 is again not defined. Now comes cot theta. So cot theta is a reciprocal of tan theta. Correct? Cot theta is a reciprocal of tan theta. So 1 by 0, that is not defined. Okay. Now tan theta, that is 1 by root 3 at 30. So cot 30 will be root 3. Here we will get 1 as it is, and cot 60 degree is equal to 1 by root 3. And see, at tan 90 degree we will getting not defined number. Now 1 by 0, if we reciprocal it, we will get 0 by 1. So cot 90 degree is 0. So this is the table, okay, of different functions at different angles. I hope this is clear to everyone. If you have any doubt, then please let me know. Okay, now let's move to the next part. Now we are going to learn about some identities. Okay, so there are three important identities: sine square theta plus cos square theta is equal to 1. Now let's solve it. Okay, let's prove it. So LHS, okay, sine square theta is nothing but p by h whole square, that is perpendicular square by hypotenuse square, plus cos theta is base by hypotenuse, so base by hypotenuse square. Okay, now p square divided by h square plus b square divided by h square. Now see, we will take the LCM. LCM will be h square itself. So here we will get h square. On the numerator part, we will get perpendicular square plus base square. Now we know the identity that hypotenuse square is equal to perpendicular square plus b square. So on the numerator part, in place of p square plus b square, we can write down as h square. So h square by h square. If you cancel it out, you will get 1, which is equal to RHS. Okay. So this is your first identity, that is sine square theta plus cos square theta is equal to 1. Now let's move to the second identity. 1 plus tan square theta is equal to secant square theta. Okay. Similarly, we will prove this one as well. So now we know that we will take left hand side. Tan theta is equal to perpendicular by base. Okay, so 1 plus p square by b square. In place of tan square theta, we will write down p square by b square. Now we will take the LCM and we will get here b square. And if you take LCM, so 1 into b square, you will get b square, that is base square plus perpendicular square. Now again we will use the identity of Pythagoras theorem, that is h square is equal to b square plus p square. Okay, so on the numerator part, we will get hypotenuse square divided by base square. Okay, now see, on the RHS side, right hand side, we have secant square theta. We know that secant theta is equal to is the basically reciprocal of cos theta, and cos theta is base by hypotenuse, so secant theta is hypotenuse by base. So hypotenuse by base. So if we write down h by b in place of secant theta and whole square, we will get h square by b square, which is equal to your LHS. So this is your second identity, that is 1 plus tan square theta is equal to secant square theta. Now let's move to the third identity. Third identity says that 1 plus, so third identity is 1 plus cot square theta is equal to cosecant square theta. Right? Again, we will prove it. So take LHS part. Now LHS, that is 1 plus cot square theta. We know that cot theta is equal to your base by perpendicular, that is reciprocal of tan theta now. So we will get here 1 plus b square by p square. If you take LCM, so on the denominator part you will get p square, and on the numerator part you will get p square plus p square. Now we will use the Pythagoras theorem again, and which is p square plus p square, which is equal to your hypotenuse square by p square. Okay, so this is your LHS side. Now RHS part. RHS is cosecant square theta. Cosecant theta is basically reciprocal of sine theta. So in place of cosecant theta, we can write down p h by p, and whole square of it, we will get h square by p square, which is equal to your LHS part. I hope this video, this small session is clear to you. And now if you have any doubt in the basic part of trigonometry, then please let me know. Okay, thank you. Have a good day.